Hi guys, I'm back again with another video, another vibe. Just on my channel, it's Math Time, question and answers, where I give you insights on all the complicated questions giving you problem at school. Today's question, we are going to dive into Cameroon GCE Board 2021 paper 2 question 5 section A. In this question, we are going to be talking about logical expression, which says that we need to draw a truth table of a compound statement that is given to us, as you can see on the screen. Okay, before we dive into this question proper, I would like us to note certain things about logic. The first thing we need to know is what a statement is. A logical statement is simply a sentence that can only take two values, meaning that sentence can only be true or it can be false, but not true and false at the same time. For instance, if you say I'm going to school, that is a logical statement, because you can either be telling the truth that you are going to school, or you can be saying a lie that you are going to school whereas you are going somewhere else. So that is a logical statement because it can take only two values. It can only be true or false. Another example is that the lights are on. So it's either the lights are on or the lights are off. So you cannot say the lights are off a little or the lights are on a little. No, it's either the lights are on or the lights are off. So that is a logical statement. Statements such as sit down is an order. They are not logical statements. They are not considered as logical statements in this case. Now that we know what a logical statement is, I want us to understand, for the case of this video, we are going to consider two statements, a simple statement and a compound statement. A simple statement is simply a logical statement that cannot be broken down into further statements. For instance, I have a pen. It's either you have a pen or you don't have a pen. So this statement cannot be broken down into any other statement. So we call such a statement a simple statement. But a statement like I have a pen and a pencil is a compound statement because it's from two statements. I have a pen, I have a pencil. So if we bring these two statements together, they form what we call a compound statement. That is what we have here on the screen. We have P and Q, and then we have negated it. Negation of P and Q. So we have two different statements that have been combined together to give us one statement, which we call a compound statement. So for us to be able to draw this truth table, for simplicity, we are going to still break this compound statement back into its original simple statements. If we do this, we are going to have two simple statements, P and Q, and then the next statement is the negation of P and Q. So this compound statement has two simple statements, P and Q, and the negation. Okay, with this in mind, how then can we proceed with this question? The next thing is to do is that we are supposed to draw a table. But are we just supposed to draw a table? We need to know the nature, how the table looks like. So we have inputs, we are expected to draw outputs. So the first question you are going to ask yourself is, how many combinations of outputs am I going to expect? So in this case, we have two inputs, so we are going to expect 4 combinations of outputs. How did we get 4 combinations of outputs? This is simply by applying the formula 2 power n, where n is the number of inputs in that question. So in this case, we have two inputs, P and Q. So we have 2 power 2, which will give us 4. So if we have just one input, we are going to have 2 power 1, and 2 power 1 is 2. If we have no input, then we are going to have 2 power 0, which is 1. So if we have 3 inputs, similarly, then we are going to have 2 power 3, which is we are going to have 8 combinations of outputs. So with this in mind and this in this case in particular, we have just two inputs, so the table is just going to be a short table. So we are going to have 4 combinations of outputs. So we expect our table to have 5 rows, not 4. 5 rows, because we are going to use 1 row for labeling of inputs. We need to indicate this input is P, this input is Q, this output is this, and this output is that. So that is why we have 5 rows. Okay, so that's the table there. So this first row that is in red is our headings. We are just going to put headings, and this, the second to the 4th row, is what is actually going to give us the combination of outputs that we expect. So let's call the first column P, we call the second column Q, and then we have what, the first simple statement, which is P and Q, and then if we combine this simple statement and then we negate it, we are going to have an overall output, which is P and Q, negation of P and Q. Okay, so now let's fill our table. If the first input P is true, the second input Q can also be true. If the first input P is true, the second input Q can be false. If the first input P is false, the second input Q can be true. And if the first input is false, the second input Q can be false. So those are the maximum number of combinations of inputs that we can have for 2 inputs. Okay, with that, we are going to look for the first the output for the first simple statement P and Q. Before we get into P and Q, I want us to know that P and Q can be viewed, can be worked on just the same way as we work with multiplication in mathematics. So P times Q, the same. But before we get there, I want us to know that another way we can represent true and falses are by representing them in order of 1 and 0. Some people represent them as on and off. Some people say they are high and low voltage respectively. So whenever you see T, true, you can say it's a 1. So for us to be able to see how it works clearly, let's put beside each true or false a value of 1 or 0. So the first case for P is true, so we'll say true is 1. The first case for T is 1 as well. False is 0. False is 0. For Q, true is 1. False is 0. True is 1. False is 0. Now we can easily work on this to get P and Q. So for the first row, true times true, which is 1 times 1, is 1. And we said 1 is true. So P and Q in that case will be true, because 1 times 1 is 1 and 1 is true. 1 times 0 is 0 and 0 is false. 0 times 1 is 0 and 0 is false. 0 times 0 is, yeah, you are right, is 0. And what is 0? 0 is false. That's clear. So that's the output of P and Q. So from there we can conclude that an AND can only be true if all the inputs are true, and is false if any of its inputs is false. So even if you have 100 inputs and we are using an AND gate or an AND expression to combine these 100 inputs, then it can only have an output of true if all of the 100 inputs are true. If just one of the 100 inputs is false and 99 of them is true, we are going to still have an output of false. Okay, with that in mind, we already have an output of P and Q. Let's now see a negation of P and Q. So negation simply means what? We invert it. So at times we call the negation an inverter. So if the input at that case is true, then it will give us an output of false, and if the output is false, it will give us an input of true. So in this case, P and Q, if we negate P and Q where P and Q is true, the output will be false. If we negate P and Q where P and Q is false, the output will be correct, true. And if we negate false again, we are going to have true. And if we negate false again here, we are going to have true. So guys, that's how we handle compound statements in logic. So if you have any questions, don't forget to comment in the comment section. If you have any questions you want me to help you resolve, please post them on the comment section, and before you know it, I will come up with similar videos. Okay guys, stay with me as I walk you through the next video, but please don't forget to subscribe, like, and hit the notification bell for more upcoming videos such like this. So guys, see you. Share with your friends, share with your loved ones. Love you guys. Bye bye.